Alright, let's look at the homework number 8, problem number 18. Alright, so we're gonna try to use the graphing strategy to sketch the graph of f of x equals quantity 4 minus 2x times e to the x. Alright, so let's do that. The first question, a domain. Alright, so domain of this function is, let's say, exponential function is defined everywhere for all real numbers, and 4 minus 2x is just a linear function, and it's defined everywhere. So the product of those two functions will be defined everywhere. So domain of this function is all real numbers. So that's why we have that here. Right? So that's easy enough. All right. So let's find the intercepts. All right. So Alright, if you want to find, say, y-intercept, right, then what you need to do is we set x equals 0. Oops. Set x equals 0. Right? So which just means that you just plug in 0 for x. So we just have to find f of 0. Right? So if you plug 0 in here, so 4 minus 2 times 0 is 4. So I'm going to write 4. And e to the 0. E to the 0 is 1. So it's a 4 times 1 is going to be 4. Right? So y-intercept is 4. And if you're looking for x-intercept, then we're going to set y equal to 0. Right? So we set the whole function equal to 0. So you have 4 minus 2x e to the x, and set that equal to 0. Right? Then since e to the x is never 0, it's actually always positive. So only way we can make this guy equal to 0 is 4 minus 2x equal to 0. Right? So we can just add 2x to both sides. So you have 4 equals 2x. Then we can just divide through by 2 to isolate x. Right? So x-intercept is 2. Alright, so let's go back. Alright, so it's x-intercept is 2 and y-intercept is 4. So that's why the answer is C. Alright, so let's look at the asymptote. Alright, so for the vertical asymptote, we need to have a function either blowing up or blowing down at that point. But you can see that if you this function, it never blows up or blow down. So we don't have a vertical asymptote. But the horizontal asymptote, we can do this. So you can take the limit of this function at infinity. So you have as x approaches positive infinity. Right, so you have 4 minus 2x e to the x. Right, and then we can do a limit as x approaches negative infinity. Right, 4 minus 2x e to the x. Right. So let's look at the top one. Alright, so we have this function as x approaches infinity. So we can see that this part, it's a 4 minus 2 times really big number. So this guy is going to approach negative infinity. And e to the big number is going to be a still big number. So that's going to go to positive infinity. Right? So positive big number times negative big number is going to be a negative big number. So we have negative infinity. All right. So what if x approaches negative infinity? All right. So what we can do is I'm going to actually rewrite it this way. Limit as x approaches negative infinity. And I'm going to put the 4 minus 2x on top. And multiplying by e to the x is the dividing by its reciprocal, which is e to the negative x. Alright. Then as x approaches negative infinity, you can see that the top guy, 4 minus 2 times negative infinity, so you're adding positive infinity. This guy approaches positive infinity. And the bottom guy is x is going to negative infinity, but there's a negative sign in front, so it's going to be e to the positive infinity, which is going to be a positive infinity. Alright? Then you can see that we can apply L'Hopital's rule since you have an infinity over infinity. So L'Hopital's rule. And the limit as x approaches negative infinity, we can take the derivative of the top, which is negative 2, and derivative of the bottom, which is negative e to the negative x because of the chain rule. So you have a e to the negative x times the derivative of negative x would be negative 1. Alright, then you can see that here, this guy still goes to, alright, so e to the negative infinity, so it's going to be positive infinity. So with the negative sign, it's negative infinity. So negative 2 divided by a huge negative number would be dividing by a big number. It's going to approach 0. Alright, so this will give us a horizontal asymptote, which is y equals 0. Alright, so let's go back. Alright, so asymptote, the horizontal asymptote of y equals 0, vertical asymptote is none. Okay, so that's why we have A is the correct answer. Alright, so let's look at, let's see, we're going to look at the first derivative to talk about the increasing and the decreasing behavior. Alright, so let's do that. Alright, so we want to take the derivative of this function. So first thing I would do is, since there's a 2 in common, so I'm going to pull out 2. And this is going to be 2 minus x e to the x. Alright, so let's take the derivative of this function. F prime of x is equal to, right, 2 is just outside. Alright, so I'm going to have to use the product rule. So 2 is already taken care of. So we have this guy times that guy. Alright, derivative of the first guy would be negative 1. And times the second guy, so e to the x. Plus, alright, first guy is 2 minus x multiplied by derivative of the second guy, so you have e to the x. Alright, so this is going to be equal to negative 1 plus 2 is 1 minus x. Alright, remember that there's a 2 in front, and you have e to the x. Right, so this is the derivative, so we set that equal to 0. Right, so you can see that, let's see, e to the x is never 0, so only way we can make it 0 is 1 minus x is 0, so x is going to be 1. So x equals 1. So this is our critical number. Right, so we can do a number line to discuss the increasing, decreasing behavior. So I'm going to draw a number line here. Alright, so put the tick marks at the critical number, which is 1. Alright, then we just need to discuss the sign of the first derivative. So you have, here's the f prime. right? So we can try probably like anything less than 1. So I'm going to try x equals 0 and x equals 2, right? So if you plug in 0 into the function, right, so 1 minus 0 is positive, e to the x is positive, so we have a positive sign here, right? If you plug in 2, 1 minus 2 is negative, everything else is positive, so you're going to have a negative here, right? So which means that the function f, so f here, is so derivative positive, so you have increasing here. So let's see, increasing on this interval, so it's at negative infinity to 1. After that, it's decreasing because the first derivative is negative. Right, so let's go back. Alright, so here, function is increasing from negative infinity to 1, and a decreasing on 1 to infinity. Right, so that's that. And let's see, local maximum and local minimum. All right, so you can see that here at the critical number, it's it's increasing, then turning to decreasing, which indicates that we're gonna have at this point. So we're looking at basically at the top of the hill. So we're looking at local maximum at 1, right? So you can see that there is a local maximum at x equals 1. Alright, so let's look at a second derivative and to discuss concavity. Alright, so let's, oops, sorry, I went too far. Alright, so let's do that. Alright, so we take another derivative, so f double prime of x. Alright, so put 2 in front, right? So we'll take care of that. And here, this is the first guy, and this is our second guy. Alright, derivative of this would be 1 minus x would be negative 1 times e to the x plus first guy is 1 minus x, right? Multiplied by the second guy. Then we can simplify this as, let's see, 2 is outside, so negative 1 and the negative 1 cancel out. So it's negative 2 x e to the x, right? And we're going to set this guy equal to 0. Right, so you can see that only way this can be 0 is e to the x is never 0, so x equals 0. Alright, so let's look at the number line again. So for the second derivative, so we have number line, and I'll put the tick marks at 0, so I'll probably put it around here, 0. Alright, then we can just look at the sign of the second derivative. Alright, so if you try something, let's say negative 1 or something like that. Alright, if you try negative 1, alright, negative 2 times negative 1 is positive. E to the anything is always positive, so this is going to be positive. Alright. Alright, then after that, so we can try x equals 1. Alright, then you have negative 2 times 1 times e to the 1 is going to be negative. Alright, so we know that original function, oops, sorry, so this is the second derivative. So if you look at the original function, on this interval, you're going to have a concave up shape. And after that, it's going to be a concave down shape. Alright, so let's see. Alright, so before 1, oops, oh, sorry. Ooh, shoot. Right, where so second derivative, right? Let's see. Right. So before that, it's a concave up shape. Before 1, it's concave up shape. And after that, it's concave down. So D is the right answer, right? Then do we have an inflection point, right? So you can see that the concavity is changing at x equals 0. So we have an inflection point at this point. So inflection point at 0, right? So inflection point is at 0. All right, now we can kind of sketch the graph, and you can see that it was increasing before 1 and decreasing after 1. So you can see that this is not following that pattern here, and B does not follow that pattern. So it's going to be either C or D, right? Then we can look at the increasing, decreasing behavior. All right, so here you have, the concavity. So before 0, it's concave up, and before, maybe I should do this. Can you do that? All right, you can see that the before 0, it's concave up shape. After x equals 0, concave down shape. So C is promising, and let's look at D. Right, D actually has the same shape, in concave up here and concave down here. Only difference is that at 1, this is going to have a value of less than 3, and at 1, this guy has the higher value, right? So if you plug in 1, you can see that you have a 4 minus 2, and that's 2 times e to the 1. Right, so e to the 1 is about 2.7, so 2 times 2.7 is definitely bigger than 1. So you can see that this is actually too low. So this is going to be the right one. So that's why C is the right answer. All right, so that's it. I hope that this was clear.